Hi. So we've been working with function notation. We're going to continue that theme, but we're going to wind up working through a couple problems on this worksheet with those three functions. So let me tell you how it's organized. So see how there's three columns. So in this column, all the way down, we're going to be dealing with the function that's just f of x equals 2x minus 1. So just a nice linear function. Okay. All right, in the middle, all the way down, we're going to be working with the function f of x equals x squared minus 2x plus 4. And then in the last column, we'll be working with the function f of x equals 2 over x plus 5. So the first function is linear. So if I were to graph it, it would be a straight line. The second function is quadratic. And the third example is a rational function. Okay, so I just want to go through and work through this. And when you come to class on Tuesday, I want you to have the first two columns. That's what we're going to do. And then we'll work on the last column together in class. But I'd like for you to be able to do the simple ones, the linear one and the quadratic one, and have kind of the basic idea. And then we'll work more on the last column and also work a little more when you get down to this area where you're not just doing f of a number, but you're doing f of a variable expression, okay? So all of this really depends on you working hard on those earlier concepts of just what does function notation really mean, what is it trying to say, and making sure you're comfortable using that notation. Okay. All right, so if we're trying to just find f of 3, so that's the situation where what you're going to do is you're just going to plug 3 in for the variable that you have. So 3 is your input. Okay, so let me go back to my black pen for a moment. Okay, so I'm going to do f of, and then 2 of, let me write it a little smaller because I've got to simplify it as well. So I'm going to do f of, and then right there where the x is where I'm going to put the input, which in this case was 3. So right there I'm putting a 3, and then I just got to work that out. So, f of 3 would equal 6 minus 1, and that's going to be 5. Okay. Well, we're going to do the same type of thing for the next one. See, this rule that we're being given right here, okay, this rule, really the x that you see there is just a placeholder. The rule is trying to tell you the process. It's trying to tell you whatever your input is, do 2 times your input and then subtract 1. So on the next example, the input is -2. So we're going to put a -2 where the x goes. So f of -2 would equal 2 times -2, and then we'd subtract 1. You got to follow order of operations or use your calculator to be sure you're dealing with order of operations in integers correctly. So you would get f of -2 equals -5. Okay. All right, now in the third example, this is the one, we've done one like this on the earlier video, but when you're doing f of a, it can kind of feel like a trick question. F of a is being used as your input. So right there where your input is supposed to go, you're just going to put a. When you do, a is a variable, so you can't really do much simplifying, and this just turns out to be 2a minus 1. And 2a and minus 1, they're not like terms, so that's the best you can do. You need to stop, okay? But I like to do that problem because I want you getting the hang of how this rule that's being described up here at the beginning is just really telling you the process that f of your input is 2 times your input minus 1. So see how the x plus 1 is inside the parentheses? Okay, when you're looking at that, it does not mean, it's not okay to think this. what a lot of people think. That is completely wrong because f is not a variable. You're not just distributing. You can't distribute. This is not f times x plus 1, okay? All right, the x plus 1 right there is really the input to the function, okay? All right, so you know that function machine we've been dealing with. Okay, the earlier ones were easy enough, we didn't have to think about it. What we're saying is x plus 1 goes in, and then f is some process that's going to act on it, and you got to tell me what comes out. All right, so f, let me keep to my color scheme here. So f of my input should equal 2 times my input minus 1. So right there where the input would be is where I put x plus 1. Okay? All right, so that means we're going to distribute the 2. And we're going to get 2x plus 2 and then take away the 1. Let me keep my color scheme. I like it to look good when I'm done. Okay. All right, so let me do my simplifying. So there, 2 should be distributed. 2 is just a number being multiplied by x plus 1. So I would get 2x plus 2, take away 1. I would get 2x plus 1. That would be your final answer. Okay, we'll put a box around those final answers. All right, and also let me comment again. If we found out that f of 3 equals 5, that's like saying when x is 3, y is 5. It's like giving you the ordered pair 3, 5. It's saying 3 went in here, and then f was some process, and what got spit out was 5. Okay, really need to be working on understanding that, or you're not going to survive the function notation unit. Okay, got to really think about that. All right, now I want you to look at the difference between f of x plus 1, where x plus 1 is all inside the parentheses, and f of x, where the parenthesis closes, and then you add 2. What's going on there is only x is going into the function machine. F is acting on it, and f of x comes out, and once f of x comes out after the fact, then you come out and add 2 to it, okay? So 2 doesn't go through the process. So you really just need to follow what the function, if you understand function notation, it really is telling you what to do. So if we're trying to figure out f of x plus 2, well, f of x, we know, we have to go back up here to make sure we're seeing it correctly. F of x in this column is 2x minus 1. So this right here is 2x minus 1 because f of x equals that, so it's interchangeable. Then we're going to add 2, okay? And then negative 1 plus 2. Wait, let me make sure because I think I might have written that wrong. Oh yeah, so f of x is 2x minus 1, and then here it's telling me to add 2. So when I do that, I get 2x plus 1 when I'm finished, okay? Let the function notation kind of tell you how to approach the problem. All right, and then this one, this f of x plus h, that one is really most similar to f of x plus 1. X plus h is inside the parentheses, so it's your input, right? It's your input to the f function. So when you do f of x plus h, you should get 2 times your input minus 1. And in this case, your input is x plus h. Okay, so now that is 2 times that quantity, so we distribute. We wind up with 2x plus 2h minus 1, but none of those are like terms, so you can't go any further. So that would be your final answer. Okay. Now I'm going to work this last one out on a blank down at the bottom. So let me just get some more space, see if I can get down here. Sorry, let me undo. Maybe it moved like I wanted it to. Yeah, there it is. Okay, it's not quite what I wanted. I want the blank paper, really. Okay, so I'm going to come down here and work the f of x plus h. Okay, let me see if I can get. A little more. Okay, so this. Okay, it's got a little page break. Here we go. All right, so this one right here, let me remind you that the function we're dealing with here is f of x equals 2x minus 1. Okay, let me make sure that was right. F of x equals 2x minus 1. Okay, so when you're looking at this, we're going to talk more about it. I don't want to really tell you what it is quite yet. I really want you focusing on this like it's a function notation question. Okay? So I think the mistake people make is that there's going to be one thing that you're going to plug into our rule right here and get your answer. But you notice that it's got really two parts. Let me do it down here a little bigger. It's got, okay, so it's got this thing here that we got to figure out, and it's got this thing here that we got to figure out. Then we'll subtract them. And then this at the bottom doesn't say f of h, it just says h. So the denominator is just going to be h. And there's a reason we're doing this. I'm not just randomly picking something weird and asking you to do it. This is a very important expression that you wind up having to use quite a bit for various purposes, and I'm going to tell you more about it later. But I want your focus right now on following the directions that the function notation is telling you. Okay, so do you see how the x plus h is inside the parentheses on the first part? Actually, we've already done f of x plus h. We did that in the previous box, right? So we've already done that. Here's how you do it. You plug in the x plus h for the x and you work it out. So you wind up getting 2x plus 2h minus 1, but then that can't be simplified, so you're done, okay? So if we had not just done that, we would have worked that out, but see, that's going to go right there, okay? So when I'm trying to do this expression, I'm thinking about, okay, what's this piece? Okay, what's this piece? And then I put that information in there. So remember how f of x plus h just equaled 2 times x plus h minus 1 in that first column. And we went through and we simplified it as best we could. It just didn't simplify very far. Okay, that goes right where the f of x plus h is. So we put it in there. That's where that goes. Okay. Now right here, I'm supposed to be putting f of x. Well, we were given f of x earlier. It was just 2x minus 1. That's what the definition of it, of what f was. And so right there, you put 2x minus 1 because f of x equals 2x minus 1. So it goes right in place of it. Now there's a minus sign in between. So we write that, and all of that is divided by h. Right? Now we're getting into just old basic algebra stuff you already know. Okay, this just has an understood 1. This has an understood negative 1. Okay, so you're just going to get rid of those parentheses. So this is going to become 2x plus 2h minus 1. The parentheses are just basically getting removed because of that understood 1 out in front. Over here, please be careful. This is a negative that you're distributing along with the 1. So you're going to get minus 2x plus 1. Okay. All right. And then in the denominator, we still have the h. Now notice on top, we've got some like terms. See the 2x here and the minus 2x here. Those are like terms, and if you were to add them up, they would cancel out. They would be 0, so I'm going to cross them out. See how this -1 and that +1, that would add up to be 0. So at that point, I now have 2h on top and just h on the bottom, and that's 2 times h. So right there, that h over h, that's going to cancel out because h divided, any number divided by itself would be 1, and I'd be left with just 2. Okay, so don't be under the impression when you see that you've got to work out this right here, that there's just one thing you're going to plug into your rule like you did earlier. It's not really like that. It's almost more like a formula. So you figure out this part if you haven't already, you figure out this part if you haven't already, and then you do what we just did. Okay? And this one just happened to turn out to be 2 when we were finished. Okay? I just couldn't fit it in that little bitty box. Okay? All right, so let's see how long that, I don't know how long that video's been going. Let me go ahead and stop this one and post it, and then I'll just post the other one separate. If I can keep them kind of short, I think it helps you be able to view it more easily.